Welcome back. In my previous tutorial, I have demonstrated how to read a BibTeX file in R and then how to convert this BibTeX file in data frame using bibliometric package. We have also seen some bibliometric analysis in R. We have seen some great visualizations using the bibliometric package. As I said, it has so many powerful functions to do clustering. You can cluster your topics. Yeah, you do lots of things. Really, it's really great package to do bibliometric analysis. But we are not going into the details of using this package. We have shown some Sankey plots or cluster maps or dendrograms or something. This is just to demonstrate the really preliminary analysis of this our reference data. If you really want to have a detailed analysis, I do recommend looking at this package. It has so many powerful functions. If you also want to do like author collaboration or citation network or keyword network, author keyword relationship and the like, I do recommend to looking at the details of the package. But today I'm not going to use this package. I just want to change. It's just for the change. Because I use bibliometric package to just change my my BibTeX files and convert them in data frame in R. So for today, I will just use a simple package. It's just a one function package. I think I'm not sure there is actually another function within this package, but it's really quite easy. So that is the way you load the library. And if you remember in my previous tutorial, I dropped this URL. So I will call this file COVID-19, and then the function that you need is BibTeX, and then what you need is use your bib file. Let's say if my bib file, if you save it in your desktop, it could be like COVID bib. So that's the file extension. That's a bib. But since I have only the URL, so I can simply use URL. If you remember in my previous tutorial, I dropped this URL just below the tutorials. You can also do your own analysis. This is the URL, and then that's what you need: BibTeX and then URL. Once you have that, it will take a little bit of time to read the BibTeX file and convert it in data frame. So let's see. So I already have COVID-19. I called it COVID-19, and I have 601 documents and 32 variables. So let's say these are the way it's organized. So you have the category, BibTeX key. It's a little bit different from the bibliometric package. The way it's it's arranged, the variable names. Let's say with BibTeX package, when it was reading, we only had 23 variables. Now if we use the BibTeX file, package, we are having 32 variables. If you see, so it's we haven't extracted all variables. So let's say the type is not known, is any. Same type is the reference type, whether this book or journal article or something. And then the key ones is actually title, DOI, page, and the author. And that's actually what you need when you cite a paper in your paper or something. Then we probably need to know the type of the data. I think for that you can also use this glimpse function. Then COVID-19. Then you can have, we have 600 rows and 32 variables, and the details of each variable should appear, I think, in no matter. Yeah. So these are the details of our variables, but we don't use all of these variable names actually, because we are doing only text analysis. I think for that we are mainly interested in the title and abstract, or maybe keyword or something. Otherwise, the rest of it is just we may use some of them, the BibTeX key as a as ID, because this is a unique ID for each reference. Otherwise, our main text analysis will be mainly on title and abstract. Yep. So let's see. If you want, you can also see the dimension, but we already have the dimension 601 and 32. Maybe we can have a look. Also DOI. Let's say how many, as I said, DOI in my previous tutorial, as I said, DOI was introduced, I think, in the 1990s. I'm not exactly sure, but it's just in the late 1990s. So let's see how many of this don't have DOI actually. So you can use the which function, and then from which function you can use the complete case. It's just we want to see how many cases, how many records don't have DOI. So it's like we can use complete cases, and then I think once you have that, what you need is you need to call your data COVID-19, then DOI is represented by DOI. So if we see that, so we have about so basically all of them have missing values, missing DOI, and maybe we can also see can actually some is NA COVID so this one is actually which columns, which columns, which rows, which of the rows within this data, which of them don't have DOI. So we have two papers, 87s, and then the 551st of the articles, they don't have DOI. Maybe we can also scroll down. My R is a little bit busy. Scroll down and see which of the articles actually have missing DOI. But that's how you find out. So this is which row number, which function, and then you check complete case, then is not complete. So and then the 87s and the 551st, that means they don't have DOI. That's how you find out. And we can also see then this number should be 2, because some is NA and the missing COVID DOI, and that should be I made a mistake. This should be 19, so it should be 2. Yeah, so this is the 87th and the 551st, so that means we only have 2 variables with missing DOI. But we can also see the text that we need, that we are interested in, the abstract. So we can see if the abstract is not missing. So it's bad enough we don't have from 601 references, 159 of them don't have abstracts. That's not a good result. So that means if you do text analysis, you need to remove all these 159 references from your analysis. Then probably we do want, because if you remember, the category is one of our variable type. So the reference type should be, maybe we can have a table of, you can just check quick table, and then we see COVID-19, then we can simply call this $sign, and then once you have that, we can call category. So since it's not detecting it, but let's see, COVID-19 category. Yeah. So that means we have about 452, which are journal articles, but the rest are miscellaneous, which means it could be book or web article, web, I don't know. It's just listed in PubMed because all of them are coming, all of these articles are coming from PubMed. Anyway, 452 are from journal articles, so they are published in journals. So I suggest we need to filter out these papers with missing abstract. We have 159 papers that don't have abstract, and then we also don't need these miscellaneous. We just need to focus on. So that's why, you see, this is we don't have abstract for 159. And that means we have 149. That means all the miscellaneous documents I expect, because this might be like book section or something. Usually book sections, they don't have abstracts. So that means most of this, I believe 149 of them will be part of these 159 documents with missing abstracts. So we do some data filtering. So let's call it COVID-19, maybe new, can call it COVID-19 new, and then let's call the first data, that was COVID-19, and then we pipe it, then filter. Let's filter. What do we want to filter? We want to filter papers with missing abstract. We want to filter them out. Abstract. So filter is any missing abstracts. This will remove all abstracts with missing, all missing abstracts, or all records with missing abstracts. That's what this will do for us. Then let's see if any of is any actually COVID-19 new, then abstract, and see if all of these all of the other ones are already removed. Abstract. So maybe let me, these are two separate codes. So COVID-19 filter is any abstract. I hope I got it correctly. Yeah. Now let's count how many. This should be 0, right? Yeah. If I do this, it should be 0. Yeah. And let's see how many of them are complete. And that should be about, I don't know, 400 something. 442. Yeah. So we have 442 records with abstracts, and that will be a good start to do our text analysis. That's where we start. So we need to use this COVID-19 new data, 442 observations, and all of the abstracts are complete, so we don't have anything to do. We just go into the details of this abstract. But well, maybe one more thing. As I said, we have this category. If you remember, we were doing category, and we were seeing 452 are journal articles, and we have about 149 some book sections or whatever, different from journal article. So let's see the same analysis for this data. So it might be, this might be a good idea to look at not this one actually, yeah. So what we need is, let me copy this, then I will replace the data with this COVID-19 new and see how many of these 442 are actually journal articles. So let's see. Yeah, so you see 60 of them are from a different reference type, but 382 of them are journal articles. So I would prefer to focus my analysis on journal articles because that's for similarity, they need to be at least homogeneous in structure, not in terms of content. Otherwise, this might be like there may be character count difference. So I do focus. I prefer to focus mainly on journal articles. So what I need to do is I need to filter this out. So to do that, let me do another filtering. So let me call it again. Actually, let me replace COVID-19 new. I can simply replace the previous data we have, and then COVID-19 new. Then I pipe it. Then after that, I do filtering. The filter should be, my filter variable is category. Category equals, what was it? This article. So I can copy this, not to make any spelling error. So I will just copy this and put it here. Then with that, I can filter out all articles with this. Otherwise, you can also use, the exclamation mark behind, and then you can still filter out. But I'm just interested only with articles, so that can filter my references. So I have 382, so that means I am only interested in these ones. So that will be a good start where to do our text analysis. So now we can do our text analysis. For the text analysis, the steps in text analysis are, you read your references. Once you read the references, you do some, some data wrangling and some data manipulation. And once you have your data ready, the next thing is that you can do directly in your text analysis. So since we already have all articles, so we can start our text mining, and there are several R packages that you can do text mining. So for that, you can use TFIDF. As I said in my previous tutorial, there is also another package called Quantida, which is actually my favorite, Quantida. And also you can have other packages, text-to-bake, especially if you are interested in word-to-bake algorithms, and more sophisticated learning algorithms like deep learning or something. If you want to do word embedding or something, I think text-to-bake makes a lot of sense. And also there is TM and RTeX tools. I think that's one of them. RTeX tools, another package. But to be honest, I don't recommend using this package because the package is not currently being maintained, and it has been written, I don't know, 7 or 8 years ago, and no one is maintaining it. If you are in travel, if you start using this, you spend a lot of time learning this package, and someday you may be in travel, and then if you ask a question somewhere in Stack Overflow or something, and nobody will help you because this is a really outdated package. So I do recommend not to use it. I have tried all of them, and I really love Quantida and TFIDF. Actually, text-to-bake is also good for if you are interested in topic modeling and the like, and text-to-bake is also interesting. Otherwise, TM can also you can do lots of things with TM. So these are really the most popular, I would say, packages in text mining in R. So for today, I will simply follow TFIDF just for the next few minutes. And there are important steps in text mining, and these the steps are tokenization. So you can do tokenization. That's one of the key steps in text mining. That means tokenization is breaking. Is a process of breaking a certain text. Yeah, you break a certain text into word by word columns. Let's say if you have an abstract that's written with 300 words, so when you do take tokenization, that means you will have 300 variables or 300 columns. Let's say if you say let's say, let's make one sentence. Let's say if you say, okay, COVID is I don't know, what should I say? COVID is a new viral disease. I don't know, you can say like that. And then so if you do tokenization, that means you will create one variable for this. You break this text into multiple tokens, and instead of this meaningful sentence, you will have only words. So that means COVID will be one column, will be in one variable, is will be as one variable, and all of this word by word, they will be changed into columns. And whenever there is another sentence, and they will be counted, they will be counted. So the number of times the word appears in a document, and that's the count. It's called simple frequency. Simple frequency. You just simply count the number of times a word appears in a document, regardless of the sequence. Let's say in this structure there is this structure, but in the next one it may be in the next sentence, in the next row it could be, or within the abstract it may be like you may say the new pandemic COVID, yeah, something like that. The new pandemic COVID causes some, I don't know, causes the new pandemic COVID has changed our life. I don't know. You may say that you may make that kind of sentence. And then this, in the first one, COVID comes first, and then the structure is different. So the sequence of the words doesn't matter in tokenization. You simply tokenize, and I mean, yeah, there are other text analysis pipelines, like the sequence may matter, especially if you're dealing with word embedding and the like. But otherwise, in this case, the sequence, it really doesn't matter. So once it tokenized, as I said, you may count the simple frequency, or you may represent it in TFIDF. That's term frequency inverse document frequency. That's really an important measure to know the importance of one word, actually, the importance of one word in a document. That's called TFIDF. So it's a weighted numerical summary, actually. It's a weighted numerical representation of how a certain word, let's say, pandemic or whatever, how a certain word is important in a document. And that's a formula to calculate. I do recommend looking at the formula. Otherwise, in this case, it's just using the package. The package can help you calculate TFIDF or simple frequency or whatever. You can simply count them or change them into this relative measure. That's TFIDF. Maybe I do prefer to write it this way. TFIDF, term frequency inverse document frequency. So as I said, the first step is tokenization. So we will do tokenization. So for that, let me call it data. Actually, data is not a good name. Maybe let me call it COVID data. And then let me call my previous data, that's COVID-19 new. That was what I just created. And then once I have that, let me select my important variables, and that's title. Actually, title is all of the they are written in caps. Title. Let me say abstract. Abstract and keywords. If I'm doing text analysis on keywords, you may want to use it. And at last, let me just select only the author. I don't need all the others. I can just simply select only. I'm actually interested only in abstract, into boiling up all the through the abstract data in finding out which words are most common, and the like. So once I have that, let me run it. So I have, okay, this doesn't exist, so this must be keywords, I suppose. Now it should work. Yeah, now we have COVID-19 data. So we have 382 observations and 4 variables. Now the next thing what we need is TFIDF, the TFIDF package. So to tokenize, TFIDF package provide us this unnest tokens, this unnest tokens. I think that's the name of the function. Maybe we need to read the TFIDF. So once we read that, let me call this tidy COVID data, and then let me say COVID data, and then unnest. That should be unnest tokens. These are all coming from, I believe they are coming, yeah, they are all coming from TFIDF package. So this is what you need. So for the TFIDF unnest tokens, what you need is the data, the output, input token. Yeah, you just define your input and output. So your input would be abstract, that's our data type, that's a text data that we want to feed our package. And then output should be word, because we want to put it in, in tokens. Maybe we can actually have a look.